When we're looking at application problems with quadratics, there's really only two options to solve now. So we used to solve using graphing as one of our options, but more or less we're either going to factor so solve by factoring and then each bracket is going to become 0, or we're going to use the quadratic formula. So when we use the quadratic formula, and we saw this in the quadratic formula node, what we can recognize is we've got x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. But the important part to kind of look at here is underneath this square root. We notice this in the note. Under the square root, it is a special property. If it's a positive number, we're going to get two answers. We're going to get plus that value, negative that value. If it's equal to 0, then we're only going to get one answer because plus or minus 0 doesn't change anything. It's the same answer. And if it's negative, we're going to get no solutions. So this actually has its own special properties. This is called the discriminant. The discriminant is b squared minus 4ac. If it's positive, we get two solutions because we can add or subtract whatever that square root is. Even if the square root's just a number that doesn't perfectly square root, we could just say plus root 5 or minus root 5. If it's 0, we get one solution, or some textbooks will say two identical solutions. Okay, we get, one solution. Okay, if it's negative, we can't take the square root of a negative number with the real number system, so this is no solutions. So if you ever get a negative under the square root, you can stop right then and just write no solutions because there's a negative value. When we're doing word problems, that will sometimes come into play. You'll be able to see right away that the word problem doesn't work, but oftentimes the word problems do work. This example is just another example of us adding stuff on. You really need to identify what the question's asking. During these word problems, they're no longer straightforward. You can no longer just get by using algebra. You need to understand what's going on. So we've got a deck that's 4 by 3. So this is 4 by 3. And it says you're going to extend each dimension by the same amount. So what that means is I'm extending this way and I'm extending this way. So we're extending it by the same amount. So that means this is x and this is x. And if we were to connect it, it would look like that. We've got a little L on the side there. We're extending both dimensions by x. So let x meters be the extension. So now, if you want to double the area, well, we know the area used to be 4 by 3, which is 12. If I want to double the area, we need to get to 24. So area equals length times width. And we know our new area is going to be 24 because our original area was 4 by 3. 4 times 3 is 12. We double that, we get 24. And now my length is going to be this whole side, 4 plus x. My width is the same thing. We're going to do this whole side, which is 3 plus x. So now length, I'm going to write it x plus 4 just because it's easier to see. And then width is x plus 3. And now we're going to simplify the equation. We get x squared plus 7x plus 12. And then we're going to bring everything to one side. So we get 0 equals x squared plus 7x minus 12. And now we have to try to solve this equation. So we need to try to find a factor, or we're going to end up using quadratic equation. So if we looked at this, now I'm going to just start on another slide here. So we've got x squared plus 7x minus 12 equals 0. You're looking for two numbers that multiply to negative 12 and add to positive 7. So you might not be able to figure that out. So let's try the quadratic formula. So we've got x equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. We're going to sub in all of our values. We have negative 7 plus or minus 7 squared minus 4 times 1 times negative 12. That's the big thing. We're timesing that negative 4 by negative 12, so we're going to have two negatives under the square root there, which is going to give us a positive number. So what we're going to have is 49 plus 48 under the square root. So we have negative 7 plus or minus the square root. 7 squared is 49. 4 times 12 is 48. And we're adding them because of the double negative. So the square root of 97, all divided by 2. So then our two answers would be, and because we're dealing in meters here, I'm not going to give a square root as an answer. I'm going to just round it to the nearest tenth. We're going to have x equals negative 7 plus the square root of 97 over 2. And that's going to be 7. So when we add the square root of 97, we're going to end up getting 2.84 and divide that by 2. We get 1.42 or 1.4. Or we're going to have x equals negative 7 minus the square root of 97, all divided by 2. And right away, I can see that that's going to be a negative value because we're square rooting 97. It's not going to be positive. We're subtracting that from 7 already. So we're going to get negative 16.8 divided by 2 gives me negative 8.4. And we can't use negative 8.4 because it's a negative value. Therefore, our extension, extend the deck 1.4 meters. Now, if we wanted to check and see if we were right, what we could do is 4 plus 1.4 times 3 plus 1.4 equals, well, that's going to be 5.4 times 4.4. And then if we were to actually multiply that together, we're going to end up getting 23.76, which isn't quite 24, but that's because we've rounded throughout the question. Okay, so this is close enough that we know that our answer then would be correct, but we've rounded. If you ended up saying this as your answer, it would technically be correct, but that's not how we talk in the real world.